Hi everyone and welcome to MathSux. This video is going to help you pass the Algebra Common Core Regents. So we're doing this one question at a time, so here is number 11. Which statement best describes the solution of a two-variable equation? So a two-variable equation, all that means is x and y. So those are two different variables. So what we're looking for is like a line or parabola, so something that describes something like that. So if you look at the first one, it says the ordered pairs must lie on the graphed equation. So that makes the most sense to me. So let's keep reading. So let's just mark it for now. So let's keep reading, make sure that that's our best answer. So the ordered pairs must lie near the graphed equation. So that doesn't make any sense. The ordered pairs must have x equals 0 for one coordinate. I mean, that can happen, but it's not a must. And choice 4, the ordered pairs must have y equals 0 for one coordinate. Again, that can happen on a graph, but not always. So the best answer here is choice 1. So now when we look at number 12, the expression x squared minus 10x plus 24 is equal to, and then we need to factor this. So we could do product sum, or you can work backwards and try, foiling each point, distributing each term to see what matches, but I'm going to use product sum. So the product here is 24. The sum is equal to minus 10. So if we want to find two numbers that multiply to 24 and add to negative 10, we know we're going to be finding two negative numbers because they'll make a positive number when multiplying, and then when summing, they'll both be negative. So what numbers multiply to 24? There's a couple of different choices, 12 and 2. It doesn't sum to 10, negative 10 though. But if you think about it, negative 4 and negative 6. Are perfect. They multiply to 24 and they sum to minus 10. So then when we rewrite this using our new terms, we get x minus 4, x minus 6. And the only choice I see here is choice 4 for that. So number 13. Which statement is true about the functions f of x and g of x given below? So we're given g of x here. We're given this nice graph. And then we're given f of x. We're not given a picture, but we're just given that this is f of x over here, which is a little weird, but that's okay. So to get a better picture of f of x on the same graph as g of x, to compare these two functions, let's now graph f of x onto this coordinate plane. So if you plug this into your calculator, you're going to get a table that tells us the different coordinates that we're going to be looking at. So that's where these came from. And it ends up looking something like this. So let's just draw it out on the same coordinate plane so we can compare them more easily. So if we look at negative, so let's start with negative 2, 0. Oh, okay, so already they have a point that matches. Negative 2, 0, negative 1, negative 1, negative 3, negative 1, 0, negative 4. Another point that matches over here. Over here, negative 4. 1, 2, 3, 4. 1, 2, 3, 4. And now let's just sketch this. So now we can compare. Notice we have these two matching points over here and over here. So now let's look at our choices. The minimum value of g of x is greater than the maximum value of x. So here's the minimum value of g of x, which is 1, 2, 3, 4. So this is minus 4. And then the maximum value of f of x, this is f of x, is 0. So no. So we know that this is not the answer. F of x and g of x have the same y-intercept. So when you look at this, yes, they do. Notice they match up. This is the y-intercept. It's always on a graph where the function hits the y-axis. So they do. So this is our answer, choice 2. Just going through why the other ones are wrong. So f of x and g of x have the same roots. So the same roots would be the same x values, which they don't, right? Because if you look at the x values, notice g of x hits the point over here and over here, and f of x isn't over here. So we know that that's not right. F of x is equal to g of x when x equals negative 4. So let's see. Let's go to when x is -4, so that's 1, 2, 3, 4. So that's over here. So notice there's no coordinate point over here, so we know that this is not the answer either. So we know 2 has to be our answer. Now, question number 14. The equation b of t is equal to 12,000 times 0.75 raised to the t represents the value of motorcycle t years after it was purchased. Which statement is true? So right away we could see that it's the interest rate formula. So I have it written down over here. So I'm just going to make it a little bolder so we can see it. A equals PR to the t, where P is the principal. So just a little reminder of what everything in this formula is. The principal, this is always the initial. R is the interest rate. This is usually a decimal or a percent. And then T is the years. So knowing that, so we could see that our principal, what we start with, is $12,000. This is our rate. And then T in years is just, we don't know what that is. T is in years. So which statement is true? The motorcycle cost $9,000 when purchased. So that's not true because it was $12,000. 2, the motorcycle cost $12,000 when purchased. Yes, so that's our answer. Okay, up next, question 15. So this is a fun one. This is just like a nice solving question. So let's just write this on the right side over here. Let me move this over actually. So we have x plus 4 squared minus 2 equals 7. So just to solve this, let's move over the whole number first. Add 2 to both sides. We get 9. And then the x plus 4 squared comes down. And now to get rid of this squared, we're just going to take the square root of both sides. So this is a little tricky because when you take the square root, don't forget that plus or minus sign. So now the square root goes away, and we're left with x plus 4 is equal to plus or minus 3, because the square root of 9 is 3. And we're just bringing down that plus or minus sign. So what this does is we end up having two different equations. We have x plus 4 equals 3, and we have x plus 4 equals -3. And now we're just solving for x for each equation. So we have -4, -4, -4 plus 3, or 3 minus 4, however you want to look at this. This will be -1 equals x, and then over here subtract bar from both sides and we get -7 is equal to x. So if you look for our choices, we see that it's choice 3, -1 and -7. 16. So this is a weird one. Which expression is not equivalent to -4x cubed plus x squared minus 6x plus 8? So the easiest way to answer this is to just distribute each equation and see which one matches up. So which one doesn't match up actually. Look at this first one. This first choice, x squared times -4x plus 1 minus 2 times 3x minus 4. So let's just distribute these. So when we distribute this, we get -4x cubed plus x squared. And now distributing this 2 minus 6x plus 8. And you'll see that we got this. So we know that one is, since it is right, we know that this is not our answer. So let's try choice 2. We have x times -4x squared minus x plus 6 plus 8. So this time we're distributing this x to each term. So we get -4x cubed minus x squared plus 6x plus 8. So does that match our original? It does not, because we have this minus x squared here. So this is going to be our answer. And if you check these will also match this. So number 17. So which solution could model a linear equation? So linear equation, we always want things to go up evenly. So let's see what we have here. The value of a car decreases by 10% every year. So anything with a percentage, that's not going to be a linear. This would be an exponential. So that's not our answer. The number of fish in a lake doubles every 5 years. So if something's doubling, that's also exponential. Yeah, because again, we're multiplying. 2 liters of water evaporates from a pool every day. So So far this looks like the right answer. We're subtracting the same amount every day. So it's the same amount of time. It has that ratio of 2 to 1. And this looks like a linear function. So this is our answer. Number 4, the amount of caffeine in a person's body decreases by 1/3 every 2 hours. This also is exponential because we're multiplying this by a fraction. Number 18, the range of a function f of x equals the absolute value of x plus 3 minus 5. So remember, the range are all the y values on a coordinate plane, on a graph. So these f of x values. So let's just plug this into our calculator. So I put in to y equals the absolute value of x plus 3 minus 5, which is our function. And then we go to the table. So this is our graph. So we get a little sketch. Remember, the absolute values are always going to be this V shape. So we want to know the minimum here. So we know that all the y values will be the minimum and everything above it to infinity. So let's just look at we can find this by looking at our table. So if you look at our table, it has the lowest possible value. The minimum of our absolute value function is minus 5. So we know that all the y values are going to be greater than or equal to negative 5. Right? Because this is negative 5 right here. And these are all the y values. So that means in interval notation we could write with a closed bracket, because we're going to be including that negative 5, that we're going to start with negative 5 and then all the values above it, everything, go to infinity. So that will be choice 1. Choice 1. Need more practice? Check out MathSux.org for more questions. Link below. Also, don't forget to subscribe. Happy calculating!